Astronomers may have just captured something we were never supposed to see. A giant cosmic bubble surrounding a young sun-like star. Using the powerful Chandra X-ray Observatory, researchers detected a vast structure around a nearby star known as HD 61005. And what they found could be the first direct image of something astronomers have been searching for since the 1990s. An astrosphere, a massive protective bubble created by the wind of a star. But this discovery is more than just a strange space image, because this star may show us something incredible. It might reveal what our own sun looked like billions of years ago, during the chaotic early days of the solar system. So what exactly did astronomers find? Why was it so difficult to detect? And what could this giant bubble tell us about the hidden history of our sun? At first glance, the image looks simple, a single star shining in space. But when scientists analyzed the X-ray data, they noticed something unusual. The star wasn't just a point of light. It was surrounded by a huge glowing halo. This halo turned out to be a giant astrosphere, a massive bubble created when powerful stellar wind blasts outward from the star and collides with gas and dust in interstellar space. In simple terms, the star is carving out its own territory in the galaxy, and the scale is enormous. The bubble around HD 61005 stretches roughly 200 times the distance between Earth and the Sun. To put that into perspective, imagine a structure expanding far beyond the orbit of Pluto, forming a protective shell around the entire star system. But this system was already famous long before this discovery. Astronomers had nicknamed it the Moth. Earlier observations from Hubble Space Telescope revealed a strange cloud of dust around the star shaped like the wings of a moth. For years, scientists suspected something unusual was happening there. But the new X-ray data changed the picture completely. The dusty moth wings were not the whole story. They were just a small piece of a much larger environment, one powered by intense stellar winds and energetic interactions with the surrounding galaxy. And here's the fascinating part. Our own sun creates something very similar. Right now, the sun's solar wind forms a huge bubble called the Heliosphere that surrounds the entire solar system. But there's one big problem. We live inside that bubble, which means we can't easily see its full shape from the outside. That's why HD 61005 is so important. For the first time, astronomers may be seeing an outside view of a sun-like astrosphere, something we can't directly observe around our own star. Detecting this bubble was far from easy. Astronomers didn't simply point a telescope at the star and instantly see a giant glowing sphere. The discovery took years of observations. The first hint appeared back in 2014. During a short observation with Chandra, astronomers detected X-rays coming from the star itself. Interesting, but nothing extraordinary. At that point, the star still looked like a simple point source. Then came the breakthrough. In 2021, researchers aimed the telescope at the system again, but this time for almost 19 hours. That deeper observation revealed something surprising. The X-ray signal wasn't confined to the star, it was slightly extended. In other words, the X-rays were coming from a region surrounding the star, not just the star itself, and that extended glow was the key. For decades, scientists have tried to image astrospheres around sun-like stars, but the conditions required are incredibly rare. You need a star that is close enough to Earth young and active, producing strong stellar winds, and located in the right interstellar environment. HD 61005 checks all those boxes. First, it's relatively nearby, about 120 light-years away. Second, it's young, very young. Astronomers estimate the star is only about 100 million years old. That means its stellar wind is far more powerful than the sun's current wind. In fact, studies suggest the wind may travel 3 times faster and be around 25 times denser than the solar wind today. That alone dramatically increases the chances of detecting interactions with surrounding space. But there's another critical factor. The region of interstellar space around HD 61005 is unusually dense. Earlier observations showed the surrounding material may be about 1,000 times denser than the environment around our sun. And when a powerful stellar wind slams into dense surrounding gas, the collision can produce something astronomers can actually detect: X-rays. Chandra wasn't seeing the wind itself, it was detecting the energetic boundary where the wind crashes into interstellar matter. This interaction produces what scientists call charge exchange X-ray emission, a process that occurs when fast particles from the stellar wind interact with neutral atoms in space. That collision zone lights up in X-rays. And that's what revealed the hidden bubble. It's a beautiful example of how modern astronomy works. Different telescopes revealing different pieces of the puzzle. X-ray observations from Chandra, dust structures mapped by Hubble, and optical measurements from observatories on Earth. Together, they built a complete picture of a star reshaping the space around it. So why are astronomers so excited about this bubble? Because HD 61005 is remarkably similar to our Sun. It has roughly the same mass, a similar temperature, and a similar type of stellar activity. The main difference is age. Our Sun is about 5 billion years old. HD 61005 is only about 100 million years old. In other words, it may represent a snapshot of what the Sun looked like during its early life. And that early phase could have been far more violent than what we experience today. Young stars produce stronger stellar winds, stronger radiation, and far more intense space weather. Those forces can shape entire planetary systems. They influence how atmospheres evolve. They affect radiation levels. And they help define the boundary between a star system and the rest of the galaxy. There's another fascinating twist. The surrounding galactic environment also plays a huge role. Researchers point out that if our Sun were currently moving through the dense region surrounding HD 61005, our heliosphere might shrink dramatically, possibly all the way down to the orbit of Saturn. But if the moth star were located in our Sun's relatively empty neighborhood, its astrosphere could appear 10 times larger. That comparison reveals something profound. A star's protective bubble isn't controlled by the star alone. It's also shaped by the galactic environment around it. Space isn't just empty background scenery. It actively interacts with stars and planetary systems. And that idea may help scientists reconstruct the early history of our own solar system. The young Sun likely produced stronger stellar winds. It may have traveled through denser regions of gas and dust. And the heliosphere surrounding the early solar system may have looked very different from the one protecting us today. This discovery offers one of the first real glimpses of what that ancient environment might have looked like. What makes this discovery so remarkable is that it feels like a glimpse into our own past. Astronomers did not just find a strange bubble around a distant star. They may have captured the first direct image of a sun-like astrosphere from the outside, something we cannot see around our own star. By studying systems like HD 61005, scientists are beginning to understand how young stars shape their surroundings, and how those environments influence the worlds forming around them. In a way, this distant star may be showing us what our own Sun looked like billions of years ago. And if one young sun can reveal this much, imagine what the next discovery might uncover. So here's the real question. If this is what a young sun-like star looks like from the outside, what have we been missing about our own star all along? Drop your thoughts in the comments. I'm genuinely curious. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries. Your support truly makes a difference and helps this channel grow. Thank you for watching, and see you next time.